For the drill, we're going to look for the parent. The parent function is going to be y equals the sine of x. And then for part A, we're going to write the new equation. Part B, say what the amplitude is. Part C, the period. And part D, the frequency. So according to the equation, according to the scale change, the equation would be y equals 1/2 times the sine of x divided by 3. Notice that in the scale change it's 3x, so in the equation it's x divided by 3 because x lies in the equation. Part B is the amplitude, and the amplitude, remember, is the y scale change, and it's actually the absolute value of the y scale change. That looks like a minus sign. I don't want that to be misunderstood. So the amplitude is 1/2. The period is the x scale change times 2 pi, since 2 pi is the normal period. So that would be 3 times 2 pi, which is 6 pi. And then frequency is the reciprocal of the period. So that would be 1 divided by 6 pi. Make sure you write it that way. Don't write it as 1/6 pi, because 1/6 pi has the pi in the numerator. The reciprocal puts the pi in the denominator. So I just want to clarify that. All right, number 2. Same thing. Write the equation. Y equals -4 times the sine of 3 times x. Notice again, 1/3, so then this is 3 times x. The amplitude is the absolute value of the y scale change, so that's simply 4. Part C, the period is 1/3 times 2 pi, so that's 2 pi over 3. Therefore, the frequency is 3 over 2 pi. Right, this time I give you the equation and I ask you to tell me what the size change or scale change is. So that would be 5 times x, since it's x divided by 5, and -3y. The amplitude would be the absolute value of -3, which is 3. The period is the x scale change, which is 5 times 2 pi, which is 10 pi. And therefore the frequency is 1 divided by 10 pi. For today's lesson, we're going to look at the translation of circular functions. So we're going to be sliding them up or down or left or right. So let's start off by writing the equation for the image of y equals the cosine of x under each of these translations. Right, we're not doing anything to the x, but we're moving the y up 3. So that would be y equals the cosine of x. I'm going to put that in parentheses to show nothing happened to the x, plus 3. So that plus 3 does not go with the x. It's going to affect the y. All right, for part B, let's see, this time I have y equals the cosine. This says x plus pi over 2, so it must be x minus pi over 2 in the equation. And then nothing happens to the y. So I could put plus 0 if I want a placeholder, or I can just leave it. Let's go on to letter C. I have y equals the cosine. Again, x lies in the equation, so that would be x plus pi over 3 in the equation. And then minus 3. Because again, y tells the truth, so whatever happens here is what happens here. And letter D, y equals cosine of, this would be x minus pi. since this says plus pi, and then plus 4. Moving on to example 2. It says graph the parent function and A and B on the grids below. Explain how the graphs differ from their parent functions. Okay, so the first thing we're going to do is we're first going to graph the original. So we'll write some steps here. Graph parent function, that's the original. And so cosine of x. I'm going to like that. This I already know, let's see, I'm going to actually maybe stretch this out a little bit. Stretch this down a little. Maybe this. Okay. And remember, this is pi and 2 pi. These are my 4 corners. And then those would be pi 1/4 pi's. Right, so for the parent function cosine begins right here at 1, and then it's 0, then goes to -1, back to 0, back to 1. And we have what we call the axis. And the axis is the line where the distance above and below is the same. So for the parent function, y equals 0 is the axis, because I'm going to highlight it actually. If you look right here in the parent function, if that's the axis, it goes up 1 and down 1 from the axis. So the distance above and below the axis should be the same. Right? So we know that the axis for the original is at y equals 0. We call it the axis because it's the axis where the distance above and below is the same. So what we're going to do is we're going to move the axis according to the scale change. So let's look at this for letter A. We have, don't move it left or right, but move everything up 3. And the equation is y equals cosine of x plus 3. So what I'm going to do is I'm going to move the axis. So when I have a y scale change, I can simply move this axis up 3. So it goes from being at y equals 0 to y equals 1, 2, 3. This becomes my new axis. So y equals 0 is my original. My new axis is y equals 3. And I'm going to do that in a different color. And then what I do is I simply move my points. Each of these points then gets moved up 3. 1, 2, 3. 1, 2, 3. And notice this point was on the pink axis, so now it's on the purple. It should be in relatively the same place. So 1, 2, 3. Notice this point was 1 below, so this point is 1 below. This point was 1 above, this point is 1 above. Move this one up. 1, 2, 3, right there. And this one, 1, 2, 3. So there is my new translated function that has been moved up 3, and I simply did it by moving the axis. And notice, on the parent, it's 1 above, 1 below. On the translated function, it's still 1 above, 1 below, but the axis had to move. It moved up to y equals 3. Now that was for moving or translating a function just on the y. Let's look at when we translate on the x. Right, so once again, what I'm going to need to do is graph my original. Now for letter B, I'm not going to have to move it up or down, so I don't have to extend this y-axis and have lots of other numbers. So I'm doing, let's see, this one here. Do this one in a different color. Now we're going to do this one here. So I'm first going to graph my original. Again, pi over 2, pi, 3 pi over 2, and 2 pi. So this is my original. Okay. And then what it says is it asks me to move everything according to this equation. So now I'm going to, the scale change for part B is x plus pi over 2, and nothing on the y. And my equation is y equals the cosine of x minus pi over 2. This is what I'm graphing. So I'm going to move all of my points to the right pi over 2. So this point here goes to the right pi over 2, and this becomes my new point right there. This one's going to go from here to here because that's a movement of pi over 2. This one's going to move to there. This one's going to move to here. I'm going to need to extend this. So let's see, the next one would be that's 4 pi over 2, so this would be 5 pi over 2. And we would have 6 pi over 2, which is 3 pi. This one's going to move to here. Okay. And there is my translated function. Let's look at example 3. If the following functions be images of y equals sine of x this time under the translation. Okay. We're given the translation. Let's write our new equation. Y equals the sine. Nothing happens to x, and I go up 2. Phase shift. The phase shift is when we're affecting the x-axis. This is the x shift. And there is no phase shift. That's what it's called. It's called a phase shift. There is none. The vertical shift is up 2 units. And so I'm going to start off by graphing my original. Extend this. And this can be my pi, 2 pi, pi over 2, and 3 pi over 2. Negative pi. I'm going to graph that and then we'll shift it on the next video.